This video continues on with the Geneva Gear video that we've completed in the last class. So this is part 3. We are changing part of the conversation for today. Instead of talking about how to get the mating in such a manner that you can animate the product completely, we're going to reset and talk about what we really need to get done, which is lasering this on our laser here, the epilogue laser. So a couple of things we're going to talk about today, but they're more specific to setting this thing up to go to an actual laser, because we need to produce this product and see what it's going to look like and whether or not we did a good job with how it was built. So the only way you're going to see that in reality land versus CADlandia is we're going to use the laser to do that. So that's the focus of today. First thing we got to do, which was brought up by the students before I started this video, the things that we need to get done include getting the pegs in, right? And then what else do you think? We need to set it up, how we're going to lay it out for the laser, correct? Those are the two primary things we got to get done today. So that's what this lecture is going to cover. The laser that we're using is a 60-watt laser. I bought some wood that would be appropriate to this project. Going to ask one of my students, not you, I know you're looking right at me, but you're closest to the door. Can you do me can you do me a favor and bring in there's a piece of wood that's sitting on top of by where the laser is. Bring that in. A big piece of deciding how you're going to build something is you actually have to have the material, right guys? That's what my student is bringing in, and I'm going to verbalize what the material it is, so you guys hear it in the video in case you don't take this note right now. But that's how we're going to have to make sure this fits that size paper. Did you see me? I did air quotes on that, paper, because we're printing to a product, right? It's not like we're printing to paper. We're literally going to cut this. So we're using a laser, not a laser printer, but an actual laser to cut this material. So he'll bring one of the sheets in. You really make sure is he there? It's those long boards. Yeah. We got boards that are, the stuff I brought in last night. Yeah, the long boards, they're really long boards. They're longer than our laser. The bed of our laser is 24 by 24. The boards are much longer. So that's what's eventually going to come into this room. Anyways, for now, while we're waiting, how do we put the pins in? Any thoughts? With what you already know. Bingo, project geometry, because you are as lazy as I am, and this is perfect, and this is how we want to operate. Why build it from scratch on the side when you can utilize the assembly that you have? That is the ultimate goal of a 3D product. The purpose of this product is to make the design process easier, not to basically replicate AutoCAD, where I'm just going to build stuff on the side and then bring them in. No. With that in mind, my mouse is a little jumpy, sorry. I don't know why it's, anyways. I'm going to start at the bottom. Why? Because my holes are there. Like I said, my mouse is being very jumpy. I'll figure it out later. All right. When I go into assembly, I have the choice of placing a new product or what I've taught you already, which is create a component. So we're going to hit create a component. We're going to call this peg. Okay? Yeah, very boring. This time, as we discussed in the last class, we want to make sure everything is saving in the correct folder, which it is. Did you find it? It's right there on top of the laser. There's 2 stacks of narrow pieces of thin wood. And then we're going to hit OK. And we're going to build off the bottom. All right, guys? We're not going to literally make 2 pieces in this model. What are we going to... Oh, come on. The mouse is driving me crazy. Sorry. Keeps wanting to not work today. I'm not sure. Let me turn it off again. The isometric view shows us all the components together. If I go to the front view, we get to see, that's it. That's exactly what I was after. Thanks, guys. Just leave it right there. We get to see all the components, like they're stacked. You see the little pieces stacked on top of each other? So the length of the peg should be what? At least to the top of each of these items, right? At least. That's, so whatever that is, which is what? 2, 4, 6? Perfect. So we need a peg that's 6 millimeters tall. So we're going to go back down here, and we're going to go ahead and create a sketch. But what's the issue? Have we started a sketch yet? No, we haven't. So we need to create one. So the way that I start one is what? I forgot. Right mouse button. Well, that's finishing edit. What do? Just click Start Sketch, right? Now the question is, where do we want it to begin? The jumpiness is my mouse misbehaving. Okay, I'm going to use my... Sorry about that. I'm going to use this guy. We want to start from the bottom of the back wall, and we just need to make one peg. Because I'm lazy, I'm going to do project geometry, and I'm going to select just that. That's it. Done. We're going to go to isometric. I always like to build everything from isometric. Go to 3D model. We're going to extrude. And now here's the fun part. We want to extrude a particular height. Okay? So you have the option of 2 as the distance. And watch, I'm literally going to pick the top of the tallest part instead of identifying a distance. Did you notice that? Cool. So it's 0.236 inches, which is probably, if I change the units of measurement, which I did not, would be the 6 millimeters that you guys had flagged me to say, hey, it needs to be this tall. Okay, we're going to hit all right. There we go. There's our peg, the correct height. Same with everything else. We've got the relationships here. We can leave them or break them. Remember that. I'm going to turn off the adaptives for now. If you were still in total design mode, we would have to leave those adaptives on. In this case, we don't have to worry about that too much. So I'm going to I took the one off that I could take off. This one does not want to come off. It wants to stay there, which is fine. There's absolutely nothing wrong with that. We're going to hit return. There's the one peg. Okay? Now the question is, how do I get it on the other side? I'm not going to create a new one. It's the same peg, right? So I'm actually going to say, copy. And then I did Control V. I did it with my keyboard instead of right mouse button. Paste. I'm trying not to use my mouse right now because it's annoying me. So now I'm going to constrain this guy. Move this out of the way for a minute. From its center. See how it wants to go everywhere? That's what you got to be careful about. From its center, and then what I can do, try to use the mouse for this one, but as you can tell, it's jumpy. All right, come here, you. Center of this one, boom. Now I only applied it to the center. I did not drop it onto the top of that, which is okay. That could be a secondary control feature, which is making it flush to that face. Okay. Now we have everything in here that we need to literally build this in the real world, not CADlandia. Got it? Anything missing? Anything you wish was different as you look at the end profile? Say again? You're right, there is. And it's a different size, isn't it? There's a peg attached to this guy. So you're correct. So we're going to create a new peg. And then we're going to talk about, should we make pegs the same size to save on money? We can discuss that later. And then, of course, do we have a peg for these? That's another conversation. So those are a few things that we're not going to be able to resolve in this conversation. But we're going to do it in a future conversation, all right? Because we're going to find out some issues before we go straight to laser. Because we have some issues with the dowels that we might use for this. We have to identify what dowels we have. So this one's going to be called Peg 2. Yes, I am that not creative on file names. I'm going to hit OK. This one's going to go on this face. It's going to be a new sketch. Oh, stop. Okay, we're going to pick that. Did I want it on that face? Or would it have been better? Does it matter? Let me back out and you'll see what I did. In the hopping situation that we have with my mouse not helping me right now, and I don't have a spare that I'm aware of, because my spare in the room is missing its dongle. I could try you. I'm going to pause the video for a second while I fix my mouse. Okay, getting back to this, I fixed my mouse, so here we are again. I'm going to undo what I did. Because of the mouse situation I was having, I was actually selecting the top of this piece. Where should I actually start my peg? At the top of it or the bottom of it? The bottom of it, right? So now that I have better control over Miss You Mouse, I'm going to go ahead. Come on, you. What do you do when you lose everything? I forgot. What do you do? Go home. Remember that? Go home. Got it, guys? You will zoom wherever your mouse is. Remember that. That's the other piece. So if your cursor for your mouse is over there, guess where you're going to zoom? Wherever that cursor is. Just a little bit of information there. So I'm going to create a new part. This is, what do we call it? Peg 2? Because I don't have any creativity on file names. It exists already, technically. So Peg 2 is here. I'm going to delete Peg 2, or I can edit it. I just deleted it. I'm going to hit Create. Peg 2 still is there, even. Oh, it's not. That's good. I got rid of it. So I'm going to pick this back wall. And that's really where I want to start my new part. So now I'm going to go to creating a new sketch. Of course, it rotates automatically in isometric. So I have to remember where I am right there in the part. Again, project geometry. I select the circle that I want to turn into the extruded item. Go to 3D model, extrude it. Now in this case, well, how far should I extrude it? At least to the top of the star feature, right? At least to here, right? So I'm going to send it all the way up, at least to there. And then we're going to hit OK, and that's our last peg, return to assembly. Did I accidentally screw up on anything? Do I have all the components here when I go home? Is everything there? Is there anything missing? When I did the undo, you notice what's missing? The second peg. I forgot. How do I drop in the second peg? What's the down and dirty method? Yeah, pick the item in here, right? Click the item, yeah. I can do Control C and just dump it, Control V. See that? Now watch this one more time. This is important. When you do the Control C, I can do Control C. If I stay here and do Control V, absolutely nothing will happen. I need to move my mouse into the drawing area, and I need to click somewhere. Then I can do Control V. Got it? Please remember that. Okay? Otherwise, your little peg will never appear. You can't leave your mouse here and can do Control C, Control V. You actually have to go into the space, click down, and then Control V it. Now I'm going to go ahead and constrain it. Same way, this time my mouse behaves correctly. Done. I'm gonna, do I have to constrain it this way? Or can I constrain it this way? Pick the top surface. Is it okay if I just constrain it by the top surface? No, because it's gonna slide around. How about if I constrained it to this? See this? This is a third version. I can pick here, and I can pick here. This type of constraint literally nails it down and does essentially a double hitter for you. It centers it, and it locks it on that surface. Got it? It is a nice way to constrain it. So just a little heads up on that one. Then we're gonna zoom out. Everything, everything is in the picture now. This rotates obviously without regard to this part, but we agreed we're not going to deal with that. Yes. Say it louder. I did. Yeah, thanks. Yep, you're right. So here's this piece, and here's this piece. So it should be good to go. Now the last step is for the purpose of building, not, I'm ignoring the animation part. If I go up here, we discussed, we agree that that's going to be later because we want to build this thing. Animations are cool, but if the product still doesn't work, who cares? Is there anything we should think about doing as we look at this part? Should this be floating in space like this? Or do you think it should have something underneath it so it has a base? And what should be that parameter? See, these are all the things missing on the drawing that we were provided. The client gave us a nice picture, but with no context. So it was done with CADlandia in mind, but not reality in mind. This part is the base, which is holding a significant amount of this piece in place. It could be enough. Okay, so maybe it's good enough. Or do we want to build in a platform for it too? The question is, how much space are we talking about? How do we find that out? Remember that one? We have tools. We have, okay, sorry. I gave you the answer up front, but I should have. We had view, we had manage, we have inspect. Inspect was used for what? Well, whether or not we had interference, right? What's nice to know is under inspect and under tools, you get one option in both. See that? Measure. So what we want to measure is from this part to this, well, you see how it did that to this part. It doesn't really do that, does it? Nope, that's wrong. So how can we measure where we exactly want to be? In here, you're actually forced to put in some axle planes, but you really don't want an axis right in the center. Where do you want it? You want it somewhere, you don't want it through. Intersecting two planes doesn't help you. So what can you do, since you saw planes multiple times in here? See that? You can actually add two planes. See that? You can have the planes tangent. Remember that? That was, I think, a different project we were dealing with. So I can pick here, if I go to isometric, and I can throw in a plane in relationship to that object right there. Did it do it? Not yet. So let's go to isometric. Let's cancel out of the command. Should I turn my plane on first so I could look at it? It always helps to view everything. So make it, whoops, make it visible. Then you can look at the main view. Now I can put in a plane from here to this object. Done. See how fast that was? Compared to what I was struggling with a few minutes ago. Then I could throw another plane in from here to this object. Done. Isn't that beautiful? Now I can go to either inspect or tools and measure from plane to plane. 6 millimeters. Okay, that's not that far a distance. And the distance from, obviously from here to here is from this object to this object to, to this point, that's 25 millimeters. That's a lot. Here to here. That's an inch when you think of 25.4 millimeters equals an inch, right? That's an inch of its body sitting on top of the other surface. Do we really need to put another platform? Perhaps not. We have ample support. We won't really know it until later, but I think there's ample support that we don't need to put in anything underneath. So now I think we're ready to go to the next step, which is preparing this object for build. All right? So we're going to hit save, save, and save often. As you know, you get all this. So you say, okay, and you save everything. Now the thing is, what's the material? I know what I put on there. Is that why you were avoiding it? Because it's for your other 2 classes. This thing, the piece of wood that I have brought in to this room is made of aspen, so it's a nice light wood. Okay, it's not a hard wood, not that hard. It's 1/4 inch thick, nice thinness. It's 4 inches wide, okay, and it's 4 feet long. So our laser bed is 24 by 24, which means half of this will fit in the laser bed. The other half, obviously, will not. That's okay. That means I've got nice wood where I can actually use 2 4-inch wide pieces in the laser. Get it? Because I just cut it in half and put them both in. Now, it's 4 inches wide is the important piece of information. Now that I can go back. If you can put it back where you guys found it, thank you. It's 4 inches, put it right on top so nobody else touches it, because that's our wood. So it's 4 inches wide. Make a note of that. What's 4 inches in the metric system? 25.4 equals 1 inch. So 25 times 4 is, it's about 100 millimeters, a little over 100, get it? Got it? It's 101 and change, whatever you want to call it. So now where do we do the layout work to send this to a laser? Can I do it in assembly? The answer is no. That one I will tell you right now. You can't do it in assembly because all the pieces are in play. So they're in place where they're going to work. That's what I mean by they're in play. They're in their final position. The printer is a laser printer, so it's subtractive technology, not additive technology. Yes, we have a 3D printer that will do additive technology, okay? The problem is that is like watching grass grow, and this guy will probably take 12 to 13 hours to build. One. That's what people don't realize. How long does it take to make one? That's why whenever you go to shows, they're tiny little things that they do, because a 3D printer takes a very long time to make anything. During the pandemic, the height of it, when nobody could get PPEs, people were using multiple 3D printers to try to print out the visors for PPEs. I said, oh, I've got a laser. So I created visors that were off the laser. So I was cutting out visors faster than any 3D printer could build a visor. Okay? So it's definitely has its downfalls for 3D printing. That's why we're not going to use it. We're going to use the laser instead, because time is money and money is time. So there you go. So we cannot do a detailed drawing or create a layout that's going to be laserable off of an assembly. But because we put all the parts in the right place, we should be able to pull them. Got it? So that's what we're going to do. So that way we can create a sheet, a cut sheet is the term that I'm going to use. So I'm going to create new. Okay, so you know how to do standard, you know how to build models. This will be the first time I'm going to show you how to do an actual drawing, a detailed drawing. I don't care if it's a DWG or an IDW, but IDW is an inventor detail drawing, and a DWG is when you intend someone to use this using AutoCAD, because inventor and AutoCAD are owned by the same family, the same owner or creator, if you want to call it that, which is Autodesk. So all these products interface with each other. That's why you see those options. You won't see it in SolidWorks, you won't see it in Pro-E, CATIA, etc. So in our case, I'm going to go into an ANSI metric drawing. We're going to just click on that, and we're going to hit Create, because this is a metric part. And then here, the first thing it likes to do to us is create the biggest size sheet you could possibly find on the planet, D size. And what do we remember about paper size, guys? This is in your 110 class, your other classes. Okay, drafting paper size. Remember that an A size sheet of paper, B size sheet of paper, you probably had this conversation already, I'm assuming. The metric values are A1, A3, that's the metric versions. But when you look at the inch versions, that's A size, B size, C size. You ever heard those terms yet? I hope. Who's in the 110 class? Huh? The letter sizes are here. This is A size, B size, D size. Where do the letter sizes come from? Is that what you're asking me more? There is. So in a metric system, they use the same letter with different numbers. You see that? Metric sheets, A0, A1, A2, A3, A4. In the US system, they're using A, B, C, and D. D size is equivalent, you can write this in your notes. A D size paper is the same as 2, not 2. Okay, let me backtrack. I'm going to start with the biggest, which is E. E size paper is made up of 2 Ds. Okay, 2 Ds or a D size is made up of 2 Cs. It's not like the grading system, you notice that? The exact opposite. 1D is made up of 2 Cs, 1C is made up of 2 Bs, 1B is made up of 2 As, and then A size paper is 8.5 by 11. Good old fashioned 8.5 by 11 paper that you see every day when you get handouts and whatnot. So think of it in reverse. An A size sheet of paper, take 2 of them, put them next to each other, and then you have B size. Okay? 2 B-size sheets next to each other give you a C size. 2 C-size sheets next to each other give you a D size. 2 D-size next to each other give you an E size. Most printers, when you go to the store, will be at least A size. If you get a wide format color printer, the wide, quote-unquote, wide format might be the B size, okay? Because the B size paper is 11 by 17. A size paper is 11 by 8.5. Okay, so take 8.5 times 2 and you get 17. Get it? That's literally what they did. And if you're thinking about what does that really mean, that's the printing house, or the paper house, not the printing house. When you cut paper and you have a big sheet of paper, all they want to do is cut it in halves. Have it, halves. Get it? So that's how it came to be when you're thinking about what's the history of why these sizes are what they are. That's why, okay? They cut a D-size sheet of paper in half, so that's how you get 2 C-size. They cut a C-size sheet of paper in half, and that's how you ended up with a B-size. They took a B-size sheet of paper and cut it in half, and that's, voila, how you got A-size. Ta-da! That's it. So inside CAD, what the first thing it'll do is drop a D-size sheet of paper on you. Do we have D-size printer in this room? Heck no. Do you have a D-size printer at home? No. Now, more importantly, what did I say? Your paper in this case isn't going to even talk about regular paper. What's our paper this time? What's the paper? It's a piece of wood, correct? How wide is the piece of wood? 4 inches wide. So does this even matter? The fact that I put it in D size? It's the wrong size anyways, and A size won't help us either, right? So this is an example where you totally ignore the paper. Not like next week when I'm going to teach you how to do detail drawings where paper matters. Today it doesn't. We're actually going to delete the border. See that? Which is the content down here. That was the title block. Now we're going to actually delete this border as well, the basic border around the shape. We're going to go to the sheet, right mouse button, and we're going to edit the sheet and change it. It's not going to be D size. It's not going to be A size. It's not going to be the metric 0, 1, 2, 3s. It's not going to be any of these. What's it going to be, guys? Right there, custom, where I actually specify the height and specify the width. Okay, but it's in metric, so remember your math. What was the height? You cannot do math in here. You can't say 25.4 times 4. Sorry, guys. Oh, maybe you can. Hold on. Let me try it. Did it work? Did it work? Nope, doesn't work. All right. Good idea, but I think it's going to fail in practice. Okay. Let's try. Oh, it did it. Hold on. I lied. Yes. I love it when when I make a mistake online. That's perfect. Yay. It did. It did. Did you see that, guys? Guys, I lied. Watch. Woo, I love it when this happens. 25.4 times 4. Remember I said maybe it'll work, maybe, I don't know. Now, what made me say okay? Did it turn red? These are going to be my indicators for you. Did you notice how that happened? I'm like, well, I'm going to try it anyways. This is what I want you to remember to do. Whenever you're working with any software, not just this one. It's not going to break you. It's not going to destroy your, house if you try something. Good. I did that intentionally. When I typed in 25.4 times 4, it did not turn red, which means it didn't say, hey, I can't do this. Got it? That's why I said I'm going to hit OK and see what happens. Did you see how I did that? And I'm like, ooh, it worked. Got it? That's how you're going to really learn at this software product and literally any other that you ever encounter. Trust me. There's a lot of neat tools. And there's so many commands, and I'm not going to cover every single one of them in class. I just can't. We only have so many hours, right? And how much lecture do you want out of me? Jeez, aren't you tired of hearing me talk? So 25.4 times 4, and the width is going to be what? 25.4 times, what was the size of our, it's a 24 inch, right? So we have 24 inches, yeah? Beautiful. So we hit OK. There you go. That is the width of the board and the length of how much will fit inside our laser. Cool? Okay, next. Now I'm going to go ahead and bring stuff into this. So obviously I'm not going to bring the assembly because that doesn't help me, correct? Is assembly going to matter to me? No, it's not. What is nice though, because it's sitting right there, the biggest concern you should always have is, will my project fit the board? Right? So in this case, will the project fit the board? Yep, at least we can see that. The biggest piece is going to fit on the board. So at least we're happy with that. Because the scale on this must be 1:1. Remember that scale matters a lot to us. You want to make sure that the product, when it comes to moving it to an actual piece of, equipment, lasering, you cannot send it to that piece of equipment to scale, or when I say to scale, I mean to a specific 3/4 scale, 1/4 scale, unless that's what your company can do. You really want to send it to that piece of equipment 1:1 scale. And in industry, you might hear you got to send it to scale. You might hear just that. And what they mean when they say that, they really 99% of the time they mean it's got to be sent there 1:1. That's what they're really saying. We can't bring this guy in though. What we really are going to bring in is what? The base, right? The bottom, the gear. We got all these different things to bring in. So the bottom, shall we start with the bottom? Yeah? There's the bottom. So we're going to start with the bottom. And then we're going to, no, we don't need a side view of it, right? Oh, what happened? What did I forget to do? We're going to go open this. We're going to hit, not the base, but we're going to hit the bottom of assembly. We're going to hit open. We're going to move it over here, and then we're going to hit OK. That's the only way it drops, guys. You cannot jump to the next part because guess what happens? It ignores what you just dropped. Okay, please remember that. Next, we're going to go to base. We're going to bring in the next part, which is I called it the gear. We're going to hit open, and we're going to say OK. Got it? Did you catch that? Again, with the next one, we're going to go to search. We're going to pick the peg. The pegs are pegs. We're not going to laser those, right? Because we should have dowels, correct? Now, I don't know if our dowel collection is correct. That's another question. We're going to have to figure that one out. But here's something weird. We've got the bottom of the assembly, we've got the gear, and we've got the base. But the base is what? It's wrong? Oh, wait a minute. It's correct. Okay, watch. Do you see how the preview looks wrong? See that? The preview is wrong. And I can't answer exactly why, other than the way that this is saved, last saved Autodesk Inventor 2022. That's how it was saved independently the last time I accessed it. When I fixed it in assembly. And that might be why the image is wrong. I can't answer that question, to be honest. So I'm going to hit OK. Okay, this looks good, but is there any concerns that you might have outside of the peg information? Meaning, do we have pegs that are that size? So if I check the dimension of those pegs, let's jump in. So you could go to annotate and pick one of them. Do I have a peg? Come on, you. Be kind. Rewind. Nope, sorry. Yes, what question might you have? Oh, you're right. The base is not this. Is two different heights. If I sent this to the laser, best way I can do this is I forgot to bring my HP pen, but I'm gonna do it with my finger here. I'm gonna do it in red. What this is gonna laser is this outer shape, this inner shape, this circle, and this circle. So what you're gonna end up with is this, as far as a lasered product that you're going to get out of it, you're going to get that. And then you're going to get another piece that looks like that. Is that what you want? Nope. What you want, no. What you really want is this. You want this, see that, as one item with an etch of where that belongs. And it's good, I agree that you should have the hole in the middle, right? And you see what I did? I tried to visually explain what you want. Now, notice I'll use different colors this time. What's in red is going to be cut. What's in blue is going to be etched. Now, do you see why I want you to etch it? Did you see that? Why would I want this feature that I'm going to make squiggly all in blue. Why would I want that etched? Because what? Bingo! We don't want it to cut through at all. But we do need to know where that location is. The two ways we can get that location dead on, as far as the center, is obviously there's a center hole, right? But can I, in theory, put it off a little bit by accident? Is it possible that if I didn't have that etch, the pattern to use as a reference, is it possible that I might position it incorrectly? I know I'm doing those very, very badly, sorry, because I can't actually rotate this thing. But it is possible, even though it might share the same center, it is conceivably possible that I won't put it in just perfect. The only way I can do that is if I have a guide, right? The center hole is not a good enough guide. I do need an etching on this surface so I know where to glue that piece to, correct? Got it, guys? All right? So keep that in mind. So the next question will be, well, can I somehow take this and make it work? The answer is yes, but where you would do it is not here. That's a simple answer I can give you. You can modify what you have inside Epilogue's software, where you can say, I want you to be etched, I want you to be cut. Got it? But that's an Epilogue. What I would suggest would be a better approach from a manufacturing perspective is that you actually build the parts correctly. What did we do? We simply took this and extruded it from this part, right? We made it part of this piece. What should we have done? Yeah, it should be a separate part. This little centerpiece should be an independent part. Referenced off of the other part, of course, but not built as part of that part. You can't break up a part and turn it into an assembly is what I'm saying. I can't now, after the fact, break up this part and turn it into an assembly. But I can use this part to make another part and then modify it. Got it? Right? Remember that? How do we do that? I forgot. We did it with the pegs. All we do is go to assembly and create. And this time it's going to be top of wheel. Top of base, is that what we call that thing, the base? And then I'm going to pick it. I'm going to start a sketch on it. Come on, you. There we go. And then, of course, being who I am, what am I going to pick? The whole thing. Right? Then I'm going to go over here and just extrude it. And then, of course, I'm going to pick to face or to next to something, right? So what do I want to extrude it to? I want to extrude it to a spot. Now let's see where I am. It won't let me for some reason. So this one I'm going to have to put it in 2 millimeters. Oh, that's what the issue was. The issue wasn't, it wouldn't let me. I forgot to pick the face. I was going too fast. Now I extrude it to that face and I hit OK. There's my new part. Ta-da! Is that not gorgeous? Isn't that wonderful? Yay! Now, that's actually the better way to do it. Because you're going to build another part anyways. You need to adjust your assembly so that your assembly is correct to reality land, not CAD land. CADlandia is wonderful, but guess what? We live in reality. Products have to physically be built, not just exist in CAD. Cool? And that's what we're doing. So now we're going to hit, we're done. We've made our part. We're happy with it. And are we good? We can just rock and roll? Or should I fix something? How about fixing this guy? and remove that feature from it, right? Because we know it doesn't exist there. So the base now has to be edited. And that last extrusion that I put in here, this guy needs to be deleted. Now watch what happens. Oh, darn it. Undo. Remember? We used its original to make this. So how do we fix it? We're going to edit the feature and extrude to what? Instead of 4, we're just going to extrude to what? To face, remember? And then we're going to hit OK. Poof, there we are. And then we return, and then I get my error message. That's what I was waiting for. What do you think this error message is about? Remember, I used the top of it to make my new part, right? Is the top of it where it was when I made the other part? No. This is saying in my assembly, errors occurred during update. The reason the error occurred is when I made this last, there you go, the flush is wrong. See that flush? Because I made it off of that face. So when I created this top of base, what was it? It was created in reference to where that original extrusion was. So if I remove the adaptive, okay, remove that adaptive element, update this, doesn't want to update. These are still a problem. If I delete it, that one goes away. This one goes away. Whoops, go home if you lose your visibility of your part. Any issues? Oh no, this thing is now moving around. Why? Because I removed the two things that locked it into its place. I need to reattach it. I'm going to use the center reference and hit apply. Okay. It's there now. Now what's wrong with it? Oof. Look. Now it rotates everywhere. Now I need to put the constraint for top of surface on it. Wrong side. Let me bring that in a little bit. There we go. It always helps if you can see what you're going to constrain a part to. Hit apply. Now what's wrong? Location, right? We need this to be aligned with what? Whee! To the peg, right? Because now they move independently of each other. Why? Because now this is a separate part, as it should be, yes? Now, you got to remember your constraint rules on how to realign these. First thing I recommend you do is, of course, turn on your planes that help you with alignment. So I want that one visible. Then I want this guy turned on as well. As far as that, there's the base. I got to get those planes in. I got to view those planes. Hold on, open that up. Which one works? That one. Okay. Whoops, did I turn visible? No, I did not. Make sure it's visible. And then I can take these two planes and lock them into each other the correct way. Pay attention to that little detail. I could flip it, whee, back and forth. Hit apply, and we're done. Now this product behaves as it did before. See that? But it is physically correct for production, which is the whole point. Save everything, save, and save often. Trust me, you need to save, and save often. And look! Look! What happened here? It updated on its own, didn't it? Is that not beautiful? That one then now I can delete this one because I don't need it anymore. This is correct, right? We need a circle and a circle. Oh, crap. Is it correct? Did we want the etch in there? Yeah. How do we fix that? I want that etch in there. That's this guy. I see all the different extrusions. See that? This one? What can I do? It's in there. Doesn't matter what I do to its layers. Scale, line type, nothing. Why? What's the... What can I do to make it visible? If I double click on the view, you get a series of options. One of them is hidden lines removed. Hidden lines. There are no hidden lines. Another one is shaded. None of this matters. You notice that? Why? When that extrusion was created to fill the center, it was blended into the rest of the part. How do I bring in the shape of the other feature into here? Okay, that's the question that you're trying to answer. I'm going to wait a moment because first I want to bring in, before I answer it, the piece that we added, which is, what is it, top of base, we called it. And we're going to open that guy and drop it in here. So that's good. We're going to hit OK. This one is fine. See that? But we would love to have this feature visible in here. When you go back to the part and you open it, there's a few ways to do this, but I'm going to show you one method. This extrusion, the sketch is not visible. What I can do, though, is pick that extrusion now the sketch is here because we shared it. See that? If I edit the sketch, that's the parent sketch. It's been shared twice. Shared here, it's shared here. It's been shared into this whole thing. If I right mouse button, it says visibility, that it's visible, but I can't make it appear. So what I'm going to do is pick this face, I'm going to create a new sketch, and I'm going to share, I'm going to not share, but I'm going to project the geometry of the old sketch into this. The question is how. So I see a lot of the other features, but what am I missing? Which one is missing, guys? Everything's visible, but where is it visible? Underneath. It's visible on the bottom of the product, not on the top. Okay, so what do we notice here in this in this bottom assembly? Which side is it showing me? The top or the bottom? Watch. I'm going to project geometry. I'm going to go here. Okay, see that? I'm going to hit create. That's the, let's say, the top and the front, if you want to call it that. And then I'm going to project geometry one more time so you see the underside of the object. Create. It doesn't, because it's symmetric, it doesn't seem to care what's going on underneath it. You notice that? the solid bodies that are in there. Nothing lets me see the actual sketch. So that, if I pick this, what can I do? Can I view it differently? No, doesn't give me that option. Manage it differently? Nope. So when it comes to etching, guess what I'm going to tell you to do? One method, it isn't the only method. There are two ways to make it work. One method is I actually create the feature in here. Okay? Meaning that when I open this, I can edit the view, but I'm not editing the view. It doesn't matter what I do to it. I'm not going to get what I want. Display options, tangent edges, there are no tangent edges. Threaded feature, there are no threaded features. When it comes to components, cut inherency, nothing's in here. Model, there's nothing in there. Got it? When I go into the part itself, this one right here, in here I can create one more feature, which is an etch, which would be an etch. I can create a new feature, but how do I want to do it? This is the second sketch I created. What do I want to do? I want to share it, right? How do I share? I've taught you this one from the beginning of the semester because it's such a useful tool. Now you know why. I'm gonna what? Share it again. I can export sketch as, that doesn't do anything to me. Export sketch as, that doesn't do anything for me. Or does it? That is one way. One way is you export all your sketches into AutoCAD, and then I deal with this in AutoCAD. But I want to deal with this in Inventor. For those of you yelling, why don't you do that? That's because I'm in an Inventor class, guys. What am I going to do? I'm going to go to Extrude. I'm going to pick this. You see this? See this? This face. Uh-oh. Why does it want to do that? Because it's automatically a what? A cut. I have to change it to not be a cut. But it's going off of where, guys? The top or the bottom? The bottom, right? Do I want it on the bottom? Seriously? No. I would like to be able to do what? Off the top, I'd like to start a new sketch on the face. I would like, on this face, to create a new sketch. But I would like to share this one more time. Project geometry of just that item. It won't let me. What are my choices? Project cut edges. Was this a cut edge? Ooh, did you see that? Did you see that? Project cut edges, and I pick an edge. See that? I pick both of them. It only wants to let me. Why? There we go. I had to hold my control key down to get it to select both. There's my sketch. Uh-oh. Did it go there? If I edit my sketch, why isn't it there? Go one more time. Project cut edges. But it won't stick. What's it doing? Is it a cut edge, guys? Is it geometry? What is it? What was it? Do I need to create a new sketch? No. What am I trying to create? Just an edge, right? So my trick to you, it's one method, it's not the only method, I'm just giving you an idea. Not an actual, this is the only way to do it. I'm going to edit my feature and extrude it. Guess how far? 2.01. Why? So I can get a small sliver of an edge. Am I 3D printing this? No. I am lasering this. That's the only reason I can do this. I went 01. I mean, that's like ridiculously tiny. Now, when I hit save and I exit out of this, now it appears again. Ta-da! All of it. So now what do? I gotta take this guy. We want that as a whole, right? But we want this as something else. What do we want that as? When we go into its properties, I want it maybe as a little dot. See that? And I want this guy also to be what? Go into its properties. I want to change that to a little dot. See that? That way it doesn't laser through. Cool? That is my visual cue to the programmer, whoever is going to do the lasering. If it's not you, you always have to assume it's going to be a third party. Never assume it's you doing all the work. We know that, right? And there you have it. That's where you get your basic shapes. Now the only question is, do we have the correct dowels? If we don't have the correct dowels, let's hypothetically speaking, we don't have the correct dowels. What can I do to fix it? On the fly. Watch. If I'm in here in assembly, I have the opportunity, come on you, zoom out. It's jumping again on me. There we go. See that? Zoom all. See this one? Zoom window. So I'm going to zoom into this window. Hypothetically speaking, the pegs we have are wrong. What do? Scrap the whole project and start? No. I can literally edit my holes here by the following feature. When you go to annotate, do not use the manual methods of dropping your dimensions. Okay? Do not use the manual method of dropping dimensions. I'm going to pick one of these objects, right mouse button, and you see how it's got generate, get model annotations, all this fun stuff? See that? Did we use any dimensions on anything? Which one did we use dimensions on? This guy, right? The base? Is that the one where we used dimensions on? You see how it says annotation visibility? Do you see that? Get model annotations. Do you see that? General dimension type projected. If I click get model annotations, what do you think is going to happen? If I try to click on one of these and I right mouse button, if it has it, I want to drop in the model dimensions. How do I do that? I can't do it here. Is there something in annotate that can help me? When I look across the ribbon, about halfway through, there's something called Retrieve Model Annotations. Okay? This is inside detail drawings. When you click on this, it asks you, give me a view. Isn't that beautiful? And you hit apply. You can pick another one and hit apply. Wherever you assign dimensions, hit apply, it will drop dimensions. Now notice, did we put any dimensions in the last part when we made it? This guy was a product of this guy, right? So notice how it has 0 dimensions on it. That is the curse, is the way I'm going to phrase it. When you do this, when you use this tool, of using one part to build another part, the dimensions won't exist in that part, so you have to put them in manually. Like here, the slot sizes on this thing were created by actually using this guy. So therefore, you have no slot information on this detailed drawing. Okay, that detailed item. So the question might be, do we have 5mm dowels? And I'm going to hypothetically tell you no. What we have are dowels that are a different size. So guess what? I'm going to edit. Not this, but watch the actual dimensions. Not edit as in the dimension, like edit the dimension, which is kind of like what textile, where is it centered, all that kind of stuff. I'm actually going to pick edit model dimension. When you click on this one, instead of the whole diameter being 5mm, let's say I've got 1/4 inch dowel out there. So it's 0.25 times 25.4. And I'm going to hit enter. Look what it did. It updated it. It literally updated that item. And let's say I'm over here, I'm going to say the same thing. I want to edit model dimension here. Instead of 11mm, let's say I have 1/2 inch dowel. So I'm going to say 0.5 times 25.4. It updated it. That's an excellent question. The actual model updates as well. Now the question is, does it impact everything else? That's the bigger one. Because of how we modeled it off of each other. So that'll be the bigger question. Did it update everything? So if I update everything and I say yes to all, and I hit OK, the question of the moment is, did the slot modify itself and everything else? What did I do, which was, this is where the flaw in my logic before comes from. Because what did I tell you? Whoops, sorry. What did I tell you before? Unassociate the parts so you can move them around, blah, blah, blah. Well, guess what that did? It unassociated this. So if I go into this guy, open that part, not edit the view, but I want to actually open the part that it's made out of. I can't do it straight here. What do I have to do? Pull it over here. There's the gear. If I go ahead and open that file, remember I broke those relationships, right? So if I open this guy, this was an extrusion, this was an extrusion. A lot of this was built off the other item. So the relationships are missing. See, if we had any, the only relationship it has now is that. You have child-parent relationships here, but that's it. You don't have it hot linked anymore to the other part. That was lost. Because of that, when I go in and fix this, if I go in, I have to manually edit this. Okay? Because that relationship that I had with the slot, you see this one? That yellow reference, that was the original size. That was from the other drawing. So I would have to go in here and see that, adding the dimension over constraint, choose accept to create, cancel. Okay. So where is the parent dimension? That's the loss that you get, because this is locked in, but what is it locked into? It has a reference here. See that reference? But that reference was disassociated, show all constraints. That was a reference to a part that now no longer exists. I would have to delete that reference and fix this part. So what should I have done? Obviously, I'm doing this after the fact to make a point. Should I have removed those associations so quickly? No. I should have made some acceptances up front and said, wait a minute, I won't be able to move this part around freely, but Now I can make sure I have other things done. That's one approach. What's the other approach? I should have known what pegs we had access to up front, then I wouldn't have to go fix this. Got it? But this I wanted you to experience. I wanted you to see what happens. The beauty of the product is I can leave its automation, and if I had left the automation in it, the hot links, not only would the part itself had updated, all of its related associated parts would have updated at the same time. Got it, guys? Got it? Okay? So be fully aware of that. So that's the lesson that I wanted to get through, to show you how you can use the power of the product, but at the same time, you can also lose some features. This cannot be lasered with all this text on it. You'd have to remove it. I just showed the peg information just for conversation. We're going to complete that in class instead of on a video to verify the dimensions. So this weekend, when you're working on this, leave all your links there if you can. Don't disassociate them. And then on Tuesday, we're going to discuss what dowel rod material we have. We'll do that. All right, guys? And that ends this presentation.